Energy consumption has grown exponentially over the last decades. It is a phenomenon that probably won't be reversed anytime soon. Given the limited resources present on our planet, it is mandatory that we find new ways to produce and store energy. We decided to focus on storage, and this is with this objective in mind that we got interested in graphene, the seemingly miracle material that could revolutionize energy storage. Currently, phone batteries are mainly made with lithium-ion technology. It's a mean of storage based on a chemical reaction between an anode and a cathode, just like any other classic battery really. The main issues regarding lithium-ion batteries are the safety, or lack of. Namely, fire hazards or explosions tend to happen when left charging for too long, or when the batteries are too old. Also, there isn't any process currently existing to efficiently recycle lithium batteries, or batteries in general, but this could very well change with the rise of electric cars. Could graphene compete with lithium-ion batteries? This is what we are going to analyze next with a few key points, focusing on the main issues previously mentioned.
Graphene is an allotrope of carbon consisting of a single layer of atoms arranged in two-dimensional lattice. Graphene was discovered in 2004 by Andrei Ghem and Konstantin Novoselov. This discovery earned them a Nobel Prize in 2010. Scientists realized that graphene had very interesting properties. Indeed, graphene is a very fine material. As a result, it does not take up much space. Then, it is a flexible material. For example, it can expand up to more than 25% of its initial size. Finally, graphene is very resistant, as it is harder than diamond. Its properties could revolutionize many areas, but it's very expensive to produce graphene. For example, covering a pinhead with graphene costs €900. In this way, graphene production process must be improved. In order to overcome this obstacle concerning the production of graphene, researchers have invented hybrid batteries.
We also see the benefit of lithium material, since without it, lithium rechargeable batteries would not be possible. The process begins by extracting lithium brine. Firstly, we extract brine from seawater to collect the lithium, come after a chain of experiment, and finally to obtain a lithium battery. The problem is that the process emerges the pollution that touches the sea environment. We can observe three stages at play in the thermal process. Beforehand, the stage 1 begins around the battery with a change of state. The combustion process is described such the more the internal temperature rises, the more exothermal reactions increases inside the organic electrolyte. Finally, metal deposits called dendrite are formed as the battery undergoes repeated cycles of charging and discharging. In either case, they will eventually press the separator to keep the electrodes away from one another. Let's compare the different material approaches to improving battery safety, like the melting point and the resistant corrosion. In conclusion, thanks to the latest processes, we can develop new applications for graphene. Electrolysis batteries technology is like being modern. Lithium batteries suffer from slow charge times. That means slow patency over time. Graphene can be incorporated into lithium battery technology to increase all properties. It instead, batteries could also lead to new forms of personal portable energy storage, finally creating a new hybrid technology.